Hello, welcome to Math 20. I'm going to tell you a little bit about how all this is going to work. So we're going to prepare slides, and you may see this as a slideshow with PowerPoint or as a video on YouTube. And we're going to expect you to look at these before the class. We're going to cover them. And that way we can get to class and we can really dive into the material. And you'll get a feel for that. And if you don't look at these beforehand, you're going to be, you might be a little bit lost. And also there's going to be a quiz associated with each class day. And so we'll be expecting you to do those quizzes before class, and we'll turn those quizzes off before class. So if you don't look at it before class, you won't be able to hand in the quiz. I just want you to keep those things in mind. When we get to the end of the slide, I'm going to cue you that the next slide is coming up, and I'm doing that for a reason. The idea there is that if you want to go back and look at a slide, or a second time, you can do that. Let's say you didn't understand something and you want to look at it again, or you want to take a note or write something down. You can go through these slides at your own pace, which I think is important. Now, if you're looking at these as a video, you won't have that. It'll just be straight through. It'll be continuous. So you'll have to pause after each slide if that's what you want to do. And you'll hear me say, next slide coming up, and that way that'll be your signal if you want to pause it and go review it. So we're going to begin all the slides with objectives, and those are the key ideas that we're going to cover. And as you can see from looking at this, there's going to be a lot of review. We assume you've seen the XY plane, and you know the Pythagorean theorem, and you've seen the midpoint and distance formulae, and you also had some experience applying them. Now, what might be a little bit different today is that we're going to ask you to know where these midpoint and distance formula comes from. And by that I mean you're going to need to know how to derive them. And the reason for that is if you understand where they come from, then you are better able to understand them than if you just memorized them, because you'll know what you're supposed to do with them, I think, a little bit better. And the last thing I want to say is the Pythagorean theorem is going to come back when we do trigonometry, which will be somewhere in the second half of the course. And if you understand, if you understand all about the Pythagorean theorem, which isn't that complicated, you'll kind of see that that's exactly what trigonometry is based on. So, okay, I'm going to go to the next slide now. So, here's the Cartesian plane. I'm sure you've seen that. And just want to remind you that it's divided into quadrants, and they go counterclockwise. The upper right is 1, the one to the left of that is 2, and so forth. In quadrant 1, that's where x and y are both positive. Quadrant 2, x is negative, but y is positive. In quadrant 3, they're both negative. And then quadrant 4, x is positive and y negative. And when you have an xy coordinate, it tells you how to orient the point. So let's just use an example. Say x is equal to 3 and y is 5, so it's the point 3, 5. Remember that the x always comes first. So since x is 3, that means we go to the right of the axis, 3 notches. And since y is 5, we now go up. And when we go up, we're going to go parallel to the y-axis. That's these dotted lines. That's what they're supposed to indicate. So let's say the point is minus 3, minus 5. Well, the minus 3 for x, you'd go to the left 3 notches, and then you'd go down 5 notches for the minus 5. So again, nothing too complicated there, and something you've seen before, sure. So here we go on to the next slide. Okay. So the Pythagorean theorem, it's only applicable if you have a right triangle, and if you see the triangle where the two lines meet is a right angle, and that's really important. You can't use the Pythagorean theorem if it's not a right angle between A and B. However, there is a formula that we'll learn when we get to trigonometry called the law of cosines, which allows you to use the Pythagorean theorem for any angle, but at a cost, and that cost is there's some extra stuff after the c squared. So it's a little bit more of a complicated formula. So again, this says that the two sides squared, you add them together, and you get the square of the hypotenuse. Okay, I'm going to go to the next slide. So the first application today is the distance formula, and we want to find d, which is the distance of that line segment that you see. And just imagine walking along that line segment. It's the distance that you travel. And notice that we can sort of form a right triangle based on the x and y coordinates. The dotted lines are parallel to the y and x axis, respectively. And so we have the right triangle, and one side of the right triangle is the difference in the y coordinates. And the second one is in the distance of the x coordinates. And so if you want to find the horizontal side, you just take the difference of the x coordinates, here, x2 minus x1, and you square that. And then you do the same thing with the y coordinates. And then you add those two things together, and that should be equal, that is equal to the square of the distance. So to find the distance, we take the square root of both sides, and we're allowed to do that because if you do the same thing to both sides, that's fine. Now with the square root, want to keep in mind that unless if we tell you otherwise, we're talking about the positive square root. And so that's what we're doing here. And one last thing, if somehow you mix up the order of the x-coordinates and subtract the second from the first, instead of the first from the second, that's going to make that number negative, perhaps, but when you square it, you're going to have negative times negative, and that's going to cancel, and that's positive. So the bottom line is, as long as you have the right x-coordinates, they can be in any order. So something just to keep in mind and to be aware of. Okay, we'll do an example on the next slide, which I'll go to now. Okay, so we want to find the distance between the points minus 2, 1 and 3, 4. And take a second, I'll pause actually, and if you're following this with a pencil and paper as you should be, just, draw the line segment. Okay, so there's the distance formula from before. And so the first one's going to be the x-coordinates, so 3 minus minus 2. That's going to be double minus, that's going to become a positive. We're going to square that. So that'll be 5 squared. And then it'll be the difference in the y-coordinates, 4 minus 1. And we're going to square that. So we get 5 squared plus 3 squared. And I'll continue on the next slide, which I'll go to now. And when I continue a problem, I'm going to put the problem at the top in blue. Sometimes it might be smaller. So that way you can keep track of it. So where we were at, we were squaring 5 squared plus 3 squared. And we added those together. Now you get 34. And then you take your calculator and take the square root of 34, and you get 5.83. And generally, going to 2 decimal places is going to be all the accuracy we need. We'll let you know. And here's a check if you want to. And basically, you want to make sure that 5 squared plus 3 squared does equal 34. And as you see here, it does. So it's not a really deep check because if you made a mistake computing 5 or 3, you're not going to find it here. But it's good to check. Next slide. Okay, so here's an application. I like this application. We want to measure the distance of a pass, and the pass is from the 5-yard line toward the left side of the field to the right sideline at the 28-yard line. And notice that we put a coordinate system here on the football field, and it's worth talking about that. When you have an application to the real world, you're going to use the set of tools you have in this abstract math world in the real world. And so you get to make choices. Like here, you get to say, okay, I'm going to put a coordinate system on the football field. And that way we know where every point on the field is. Now, there's a little kind of a funny thing here is we didn't include the end zone. So that's a little weird. I would have included the end zone, but that's okay. It'll still work. So we have a pass from the 5-yard line to the 28-yard line. And notice that the x-axis is the width of the field. And it looks like the field is cut off a little bit. And then if we had the whole field, it would probably be somewhere over 50 because it looks like midfield's about 27. And then the distance is going to go all the way up to 100. So we're passing from 20 yards from the left sideline at the 5-yard line to 40 yards from the left sideline to the 28-yard line, and we want to find the length of that pass. I'm going to ask you to try that out on your own, and you can either, if you're watching this in a film, you can hit pause or just don't advance things yet, and we'll see the answer on the next slide. And one last thing is my guess is you've seen those stats where they measure how far a pass is. I'm guessing it's something like this, that they film the field and impose it, a coordinate system on it, and then use the computer to figure out the length of the pass. So anyway, work on that problem, and come join me on the next slide when you're ready. I'm going to go to that slide now that I expect you're going to wait. Okay, here I am at the next slide, and again, you see the problem up there. So we're going to use the distance formula. So we look at the difference in x coordinates. Well, that's 40 minus 20, which is 20 squared. And the difference in the y coordinates, which are the yards, or the yard lines, I'm sorry, it's 28 minus 5. So that's going to give us 23. So we do the math, and we need to take the square root of 929, and that's 30.48 yards. So again, if you need to look over this, pause or don't hit advance yet, but I'm about to go to the next slide. Okay, so the next topic is the midpoint formula, and we're dealing with the line segment. And the question is, well, what's the midpoint of that line segment? And if you look at it, you notice that the x-coordinate of the midpoint is halfway between the endpoints, the two x endpoints. See, it's 5 here, and the two x endpoints are 8 and 2. So we're basically finding the middle of 8 and 2, which is finding the average of 8 and 2. So we're going to add 2 plus 8, divide by 2 to get 5. Now you do the same thing for the y. If you notice, the height of the midpoint is going to be half the distance between where we started and where we end. And so again, that's going to be the average of the y endpoint. So we're going to add 4 plus 2 and divide by 2 and get 3. So I'm going through the formula at the bottom. There's the formula. And you just add the x coordinates together. And then you add the y coordinates together. And you divide by 2. And again, if you get the order wrong, as long as you're adding the x coordinates, you're going to get the right answer. So the answer here is 5, 3. Okay. I'm going to go on to the next slide now. So this is the last slide, by the way. And it's an example, an application of the midpoint formula. And imagine that the way this problem was given, you were given the sales in 2012 and the sales in 2014, and you had to estimate the sales in 2013. So notice that the y-axis, the x-axis is time, is the years, and the y-axis is sales. And that's pretty typical to put time on the x-axis and anything else on the y-axis. Like if we were doing time and distance for how far you've traveled, we'd have distance on the y-axis. So again, we want to. The idea here is that we know the sales in 2012, 2014, but not yet in 2013. So you have to find them. So well, that's just the midpoint of that segment. And so you add the x coordinates together. So you add the years, and you find the middle year, which is 2013. That's not too hard. And then you add the sales. So you add 13.3 for 2012, 16.4 for 2014, and you divide those by 2, and you get the midpoint, 2013, 14, 85. So that tells you that if you use this estimate, you're estimating the sales at $14.85 billion. Okay. Now, I'm not crazy about this idea, and the reason is because it's assuming that the sales are linear. And that might not be the case. The sales might jump up and down. Remember, when something's linear, it's a straight line that's the same every day. So that line says we have the same sales every day. No, it probably doesn't work that way. And probably the sales for 2013 might be different than the sales from 2014. So it probably won't be a straight line. It's probably going to be more like a curve. But anyway, I'm pointing this out because when you see an application, we're taking these math courses so you can get some sense of how to apply it and whatever you're going to study. I think it's good to look at applications you see in the book. And we have a really good one with the football field because I think that's pretty much how they do measure passes. They put a coordinate system on it, computerize it, use the computer to figure out the length of that line segment, which is the distance of the pass. And then you have one like here, which is maybe simplifying things too much to make a point. And the last thing is we were given the two endpoints, 2014 sales and 2012, and we were supposed to find the point in the middle. Well, that's called interpolation, and the inter means between, and we'll come back to that later on. So anyway, so that's it for today. Thank you for listening. I hope you got something out of it.